Here they give us a choice of a whole bunch of graphs and an equation and want us to say which one could possibly be this. So one of the first telling things, or easiest things to tell about this, is where are the zeros. So it looks like, since this is already mostly factored, this would give me a 0 of -3. And then here, think this is x plus 1, x minus 1. So I'd get zeros of -1 and 1. So I can probably rule some of these out right off the bat if they don't have those zeros. So notice this one has a 0 at -3, but at 0. So that doesn't seem like it could work. This one has one at -3, but then at 0. So that doesn't seem like it would work. This one has -3 and 0. So do we have any that even have our right zeros? Here's one that looks like -3, -1, and 1. This one, -3, -1, and 1. This one has -3 and 1, but not -1, so that one's out. So notice we only looked at zeros and we're just down to 2 graphs already. Okay, so which one of these could it possibly be? So big thing is, remember end behavior. X to the third has end behavior like this because it just squiggles over from left to right, and -x to the third goes like this. So if we look at ours, notice how even if I factored that whole thing out, my first term would be positive x to the third because I have a positive leading coefficient. All my x's here are positive. So I also need the one that has the same end behavior as x to the third. Or you could even think as x gets bigger and bigger and bigger, so put something big here, put something big here, our answer will get bigger and bigger and bigger. It won't be negative like it shows here, because there's no negative out front to make that happen. So it looks like it's got to be this one. So we're really just putting together zeros and end behavior will tell you which graph works. All right, so then let's try another equation. We'll erase our process of elimination x's from earlier. So 2x to the 4th plus 6x to the 3rd. All right, so notice I could factor x to the 3rd out of both of these. And why do I even, actually 2x to the 3rd. And why do I even care about factoring in this case? Because I want to know what my zeros are. So it looks like I have a 0 at -3 and at 0. So all these ones that don't have one at -3 and 0 are out. So this one had -3, -1, and 1, so that one's out. This one had -3, 1, and 1, so that one's out. This one has -3 and 1 instead of -3 and 0, so that one's out. And so now it looks like we're down to just these 3. Alright, so this one has -3 and 0, this one has -3 and 0, and so does this one. Alright, if we look at our end behavior on this one, see how this would be 2x to the 4th for our leading coefficient? So since it's positive, our end behavior, both ends should go up, like this one, or this one. So they would only both go down, or be, think of a down opening parabola, it has to start with a negative. So this one is out. So now we're just between these two. Okay, so if you've noticed, when a 0 is repeated more than once, so say like this one's repeated 3 times, if it's repeated twice, like x squared, that's how you get these where it just touches the axis and doesn't go through it. And so see on this one, this would have to have -3 as a 0 twice, and it would have to have 0 as a 0 twice. So it'd have to look something more like this. Whereas this one, since they cross through, they could be repeated an odd number of times. See how this one's multiplicity 3 and this one's only multiplicity 1? So it can't do this touching behavior because this is only for even functions. So say if it was like this, it could be this one. And so now we're down to one last possible choice.